Hypothalamus artificial intelligence. Presence. Make mathematical models using an expert optimization system. It is walking thinking outside the box, towards a general artificial intelligence based on mathematics, to complement artificial intelligences based on pattern recognition. Can you imagine how? An expert system is an artificial intelligence that emulates the decision-making ability of a human expert. Expert systems are designed to solve complex problems by reasoning through bodies of knowledge, represented mainly as if-then rules rather than through conventional procedural code. A robot for mathematical modeling is aimed at replacing all the systematic activities that must be performed by the mathematical modeler during the development, testing, and startup of a mathematical modeling system. The end user, in the day-to-day use of mathematical models, either manually controlled by humans, or automatically controlled by an artificial hypothalamus. Making very large-scale models by the traditional way, using a computer programmer, it is an impossible way, because the programmer only can write a limited number of lines, of good source code per period. Maintaining these models can be more complicated than doing them, if more than one programmer intervenes in the process. Considering that OPTEX is a cognitive robot, that implies that OPTEX is able to produce infinite lines of perfect source code per period. Mathematical modeling using an optimization expert system. An expert system is a computer program, software, that uses artificial intelligence, AI, to reproduce the knowledge of an expert human in a particular field. A good expert system solves a problem accurately, quickly, and is easy to use. Knowledge systems solve difficult problems of the real world by performing inference processes on explicitly stated knowledge. OPTEX, the expert system in mathematical modeling, is aimed at store in an information system the knowledge of an advanced mathematical modeler. Facilitate this knowledge for the development of new mathematical models, regardless of who has produced that knowledge, and use this knowledge to generate specialized algorithms according to real-world problems. Additionally, OPTEX provides knowledge for facilitate the development of mathematical models, incorporating content validation processes of its components, for example, validation of equations, and perform systematic tasks that are governed by mathematical rules, as is the case of industrial data information systems, whose data model is determined by the structure of the input parameters. The nuclear unit, the molecule, of a MP problem is the constraint, which is the result of integrating various types of atoms. Indexes, sets, parameters, and variables. The entities handled MEs are divided into the basic components are required to make the equations of mathematical problems. They are indexes, sets, parameters, variables, equations, objective functions, planning horizons, and sectors. As an example, let's look at the process of storing information related to the indexes, or subscripts, that are used in an algebraic formulation. The diagram presents the process of converting a MS Word table to a SQL table that understands OPTEX. As a design norm, typical of relational information systems, associated with any object, or entity, there is a master table and a set of tables that store the relationships of that entity with other entities. The screenshot shows an image of the indexes master table. Then, the modeler can explore the mathematical modeling database, following the principles of the relational information systems. The screenshot presents the master table of indexes, and all the tables with relationships with other entities, like variables, constraints, parameters, aliases, problems, data tables, and fields in the data tables. This vision implies thinking outside the box, since the relationships between mathematical elements are not investigated in the computer programs, but they are visualized in a holistic way through the exploration of a database. The process for all MEs entities is similar. From an MS Word table the OPTEX database is loaded. The diagram presents the case of read sets, which includes as data the link with the data model of the Industrial Data Information System, IDIS. From the data stored in the database, the programs associated with the algorithms of the mathematical problems are generated. The screenshot shows the case of the read parameters. For the calculated parameters, it is necessary to store the formulas in a structured way, in order to facilitate their analysis as a structured data. The screenshot shows the master table of variables, and the one related to their indexes. This data is used by OPTEX in the computer program's generation. The load of the equation includes its algebraic formulation. To be stored in a structured way, OPTEX performs the conversion automatically, from the formulas defined in the MS Word document. From the database, OPTEX generates the algebraic formulas in an optimization technology, such as GAMS. The advanced components correspond to mathematical structures that are made from the equations. They are problems, models, decision support systems, and artificial hypothalamus. The problems are defined by equations and other problems, which in turn are defined by other equations. A problem is associated to a format, like linear programming, nonlinear programming, etc. Under this approach, the inclusion, or exclusion, of a constraint in a problem is an operation of adding, or deleting, a record in the database, which is performed through the user interface. A constraint can be part of multiple problem. When the constraint is correct, it will be correct in all the problems in which it is included. Considering that the problems are defined based on sets of constraints. If the modeler has built a database of equations, such as an equation store, he can formulate as many mathematical problems as the combinatorics of constraints that can be assembled. Traditionally, a problem is conceived as a monolithic set of equations. Under a modular conception, equations are components that can be shared by multiple problems. The important thing is that each equation works properly. This correct operation will be repeated in all the problems in which it is incorporated. If a store of equations exists, constructing a problem is limited to selecting the equations that make up the MP problem, and/or incorporate sub-problems that already have associated equations. For example, the figure represents a mathematical problem related to the SAND-OP, sales and operations planning, that may be constructed based on 8 groups of equations. Production, energy, maintenance, distribution, sourcing, human resources, financial, and sales and marketing. The systems, groups of equations, that must be included in the SAND-OP problem depends on many factors, because there is no revealed truth regarding what the SAND-OP problem is. Since the equations are defined in a database, the configuration of a problem is limited to selecting from the equation store which are the ones that the modeler want to consider in the model. These visions can change within an organization. In this way, the modeler can have multiple SAND-OP models which depend on the use you want to give to the models. These models can exist permanently, or they can be created on the fly at the time they are required to be used. Similarly, the models are defined by problems and other models, which in turn are defined by other problems. When defining the problems of a model, it must specify how they are related in the solution process. For example, a model based on Bender's partition theory requires specify which is the coordinator and which is the slave. OPTEX generates RTF documents, visible and editable with text editor programs like MS Word. The RTF contains all the mathematical formulation and the IDAS data model, including the link between the fields of each table with the sets and the parameters that are read as input data. Thus, OPTEX guarantees proper documentation of the implemented models. Artificial brains and enterprise-wide optimization systems. For the year 2000, approximately, the decision support systems, DSS, were conceptualized as a set of mathematical models that exchange information between them, working offline. The first commercial management solutions was developed based on DSS concept. A decision support system must group all mathematical models, predictive and prescriptive, that uses the enterprise. Therefore, a DSS can be defined by the set of models that integrate it. Associated with the DSS must be the flow of information between the models, since it is logical that the output of one model is used as the input of another model. The traditional is that these models are used by users in a manual way, except in cases of advanced optimal control in which the models can run permanently, in real time, in an infinite cycle. The artificial brains is the evolution of DSS under the Industry 4.0 revolution that is conceptualized as a set of mathematical multi-problem models that exchange autonomously information between them, working online, using distributed and parallel optimization, eliminating manual processing. HY defines it as an enterprise-wide optimization system. The expert system of OPTEX already handles these concepts, since a DSS is made up of all the models required by a company. An artificial hypothalamus, part of the artificial brain, is an algorithm, generated by OPTEX, that can coordinate all models. The models will be triggered by events or by other models. Industry 4.0, intensive in data acquisition, extends the concept of real-time to any hierarchy of decision-making. Generating the concept of autonomous, real-time, distributed, optimization, in which multiple agents, distributed in the space, cooperate to solve an integral problem of the organization. An agent may be a country, a region, a business, an administrative department. The multiples models can run autonomously, activated by an exogenous event, for example, an earthquake, the failure of an industrial equipment, or by another model that requires processing their data. The artificial hypothalamus corresponds to a macro algorithm that coordinates the activation and solution of the models defined by the mathematical modeler. From the computational point of view, the models correspond to a set of microservices that solve problems and produce the required information, acting simultaneously and cooperatively. The concept of artificial hypothalamus can be applied to solve real-life problems from multiple points of view. In the diagram, the artificial hypothalamus coordinates models corresponding to the multiple problems faced by a company, organized from the point of view of its administrative functions. Another point of view is the spatial distribution of the problem. In this case, an artificial hypothalamus is presented for an agro-industrial company that has multiple facilities, farms, concentrated food factory, meat products factory, and stores in the food market. The farm models correspond to the same generic model, but parameterized for each farm. OPTEX manages the model families, so that they can be used in complex optimization processes, such as those based on large-scale methodologies. If an enterprise-wide optimization system, EWOS, is defined as the set of tables that make up the mathematical modeling database, a super application, that is, an application composed of several basic applications, can be defined by joining the tables of the two or more applications, ensuring that the integrity rules of relational information systems are met. The diagram shows the integration of applications for the management of public health problems, which corresponds to a regional planning problem, as experienced during the COVID-19 pandemic. To address the problem, HY developed EWOS Health, an application for pandemic management, built with OPTEX in 2021, and integrated it with EWOS HRPO, Holistic Regional Planning Optimization, built in 2006, implying that all models from the two EWOS can be used to build new models, through the mathematical modeling database, which uses a common data model for all models implemented in OPTEX, and or through equations that integrate a single holistic model. Next, HY presents its Research and Development plus Innovation project focused on generating a new version of OPTEX, which will be called OPTEX GPT. Through OPTEX GPT, the artificial intelligence of the hypothalamus will be your advisor for the best decision-making. As usual, in 1990, when OPTEX was created, the process of loading the expert system database was manual, which generated many errors and was time-consuming. As expected, the loading interface of the expert system evolved to use tables in RTF format, which can be edited in MS Word, and loaded into OPTEX using the clipboard. Normally, the algebraic formulation must be delivered to the user in RTF-type documents, which implies that progress is made simultaneously in the formulation of the model, and in the loading of the expert system. The evolution of GPT-type artificial intelligences indicates that, to keep up with the state of the art, the right thing to do is to use them to load the expert systems database. The evolution of GPT-type artificial intelligences indicates that, in order to keep up with the state of the art, the right thing to do is to use them to load the expert systems database. Finally, OPTEX, Optimization Expert System, will produce the computer programs of the model algorithms, to be executed on the appropriate computer. There are now in the world machines that think, that learn, and that create. Moreover, their ability to do these things is going to increase rapidly until, in the visible future, the range of problems they can handle will be coextensive with the range to which the human mind has been applied. In the book Human Problem Solving, wrote by Alan Newell and Herbert Simon. Thank you very much for your attention.